Hey everyone, so here's our sixth lesson in our Earth and Climate unit. We're going to be talking about feedback loops. Hopefully some of the terminology that we go through here will be useful in your final assignments for our climate unit. So why are we interested in feedback loops, and what are they is really what we want to talk about. The reason we're interested in them is that feedback loops are typically caused by small changes, and these small changes can have very large effects on Earth's climate. So these small changes can be something as simple as a small decrease in snow cover, or a small change in the composition of chemicals in the atmosphere, and these changes can end up having very drastic effects. A feedback loop, now the definition is not great here. You might start to make more sense as we get to some examples, but a feedback loop is simply just a process in which the result acts to influence the original process or the origin of that process. So I know that's kind of a complicated definition, but once we get into some examples, it might make a little bit more sense. Feedback loops make it difficult to predict the effects of changes, whether they be large changes or small changes. And they can cause very rapid shifts in Earth's climate. So for example, it could decrease the interglacial period going between ice ages, from an ice age to a warm period. And if this change is more immediate than we're anticipating, it might have larger effects on the total global climate. We have two types of feedback loops, and we'll show you again some examples so you can kind of nail this concept down. They can be either positive feedback loops, where the effect increases the original cause, or negative feedback loops, where the effect decreases the original cause. So positive and negative here don't mean good or bad. We're referring to the increase or decrease of the origin of this feedback loop. Okay. So the first example we'll do is this water vapor feedback loop, and this is the first picture in your notes. So what's happening here? We can see that as we have higher temperatures, that leads to more water vapor, and then more water vapor leads to higher temperatures. And you can see how that's going to become a cycle, right? In this water feedback loop or water vapor feedback loop, when you consider the effect of clouds, and this is kind of at the bottom there of your first page of notes where it says warmer temperature, positive feedback and negative feedback. This feedback loop actually becomes a little bit more complicated once we take clouds into effect. The more water vapor that we have usually means more clouds, and if the clouds form relatively low in the atmosphere, then they trap thermal energy near the surface. You may have, for example, noticed that clouds on a cloudy night, for example, are usually a cloudy night typically leads to warmer temperatures compared to clear nights. So the amount of clouds is going to change the temperature. Low clouds, when they exist in the atmosphere, so this is that first blank under warm temperature, low clouds create a positive feedback. Okay, so when we have warm temperatures, it's going to lead to more low clouds, which leads to even warmer temperatures. So you can see hopefully how that's a positive feedback. If the clouds form at relatively high altitudes, then the sun reflects off the clouds. The sun's radiation, reflects off the clouds and back into space. And this is going to create a negative feedback. So if we have warm temperatures, we create higher clouds, which is going to create cooler temperatures. So you can see how the initial change there, or the initial effect there, has now been changed. Right? We started warm temperature before, we've got to cooler temperatures now, and that's why it's a negative feedback. The next example is an example of the albedo effect, or the albedo feedback loop. I think I may have covered this definition before, but if not, albedo is just a material's ability to reflect incident light back out. So it's the amount of incident light or radiation that is reflected by a surface. Typically the surface of a planet, or it could be the surface of the moon or something like that. So you think of something like snow that is very reflective. It has a high albedo. Okay? Something maybe like grass or dirt would have a lower albedo than snow. So we can see these two feedback loops here. As ice melts, less of the sun's radiation is reflected by the ice. Earth's temperature increases, and then more ice melts. Okay, so that's the warming albedo effect. The cooling albedo effect would be something like ice is forming. More of the sun's radiation is reflected by the ice. Earth's temperature decreases, and then more ice starts to form after that. Okay, so you can see how these feedback loops start to work. The last example of a feedback loop is one that we are particularly concerned about. It's a carbon dioxide feedback loop. So we can see that as carbon dioxide traps thermal energy via the greenhouse effect, the global temperature is increased, and then more carbon dioxide is released from carbon sinks, and we've got more carbon dioxide in the atmosphere. To really understand this, you need to know what a carbon sink is. We've briefly touched on it before, but a carbon sink is some sort of reservoir. For example, the ocean is a big carbon sink, or oceans, I should say, are big carbon sinks, or forests. The reservoirs that, through whatever biological process or natural process, absorb carbon dioxide from the atmosphere and can store it. So we briefly talked about how forests absorb carbon dioxide. They do that for cellular respiration. And oceans also can hold in carbon dioxide, and it'll form some mineral deposits at the bottom. Oceans are great for storing carbon dioxide. They store enormous amounts of carbon as CO2 and carbonic acid. However, as the temperatures rise, the oceans can't store as much carbon dioxide. Some of the carbon dioxide that has been stored in the ocean starts to get released back into the atmosphere as temperatures increase. And this, of course, fuels the greenhouse effect. So that would be another kind of carbon sink in the ocean feedback loop. So that's it for this lesson. It was a pretty short one, I think. We're about halfway through. I think we're going to have 10 in total. So again, if you have any questions, you can leave them in the comments. You can let me know in class, and good luck on the rest of your presentations.